Simplifying radicals. So far, our examples of simplifying radicals have involved radicals that reduce to simplifying the nth root of x to the an into x to the a, where a and n are positive integers. Some radicals do not fit this frame. For instance, there is no integer power of 2 that equals the square root of 8. However, since 8 has a perfect square factor, namely 4, this allows the square root of 8 to become the square root of 4 times the square root of 2, which in turn simplifies into 2 square root of 2. Another example of a radical which is not expressible without radicals is the cubic root of x to the 7th. We can simplify it by splitting x to the 7 into x to the 6 times x. Observe, the cubic root of x to the 7 equals the cubic root of x to the 6 times the cubic root of x, which in turn simplifies into x squared, the cubic root of x. Examples. Simplify the given radical by rewriting the radicand as a product of two factors, one of which is the largest perfect power that is a multiple of the radical's index. Square root of 24. What we're looking right now for, since the index in this case is 2, we're looking for the largest second power factor of 24, the largest perfect square that is a factor of 24. When you look at factors of 24, two factors of 24, you will realize that 4 times 6 is 24, where 4 is the largest perfect square factor of 24. Now we express the square root of 4 times 6 as the square root of 4 multiplied by the square root of 6, which is, the square root of 4 is 2 times the square root of 6. So the square root of 24 simplifies into 2 square root of 6. Second example, the cubic root of 3200. Here we want to express 3200 as a product of two factors, one of which is the largest perfect cube, that is a factor of 3200. So we want to simplify this cubic root of 3200 by splitting up 3200 as the product of two factors, one of which is the largest perfect cube that divides 3200. Let's observe that when we're looking for perfect cubes factors of 3200, 8 is one such perfect cube that is a factor of 3200. 3200 is 8 times 400. Now, 400 is also divisible by 8. So I write 400 as 8 times 50. Now we're looking for perfect cubes. Is there a perfect cube factor of 50? If you prime factor 50, you realize that it has no perfect cube factors. So we conclude that the largest perfect cube that is a factor of 3200 is 8 times 8, or 64. So the cubic root of 3200 is the cubic root of 64 times 50. The cubic root of 64 times 50 splits up into the cubic root of 64 times the cubic root of 50. But we know that the cubic root of 64 is actually 4. So we end up with the cubic root of 3200 being equal to 4 the cubic root of 50. This is our simplified answer. Example number 3. Simplify the fifth root of x to the 17. The fifth root of x to the 17. Here the index is 5. So I want to split up x to the 17 as the product of two factors, one of which is the largest perfect fifth power. Now if we look for perfect fifth powers that are factors of x to the 17, we have x to the 5th, x to the 10, x to the 15. We don't get x to the 20 because x to the 20 is not a factor of x to the 17. So in this case, the largest fifth power that is a factor of x to the 17 is x to the 15. So I split up x to the 17 as x to the 15 times x squared. But that equals the square root, the fifth root, excuse me, these are fifth roots. The fifth root of x to the 15 times the fifth root of x to the 2. Last step. Obtain the simplified expression for fifth root of x to the 15. Well, that's x thirds, x to the 3 power. So our answer, our simplified answer is x to the third times the fifth root of x squared. Let's summarize the method in these 3 examples. A method to simplify radicals. To simplify an nth root, we express the radicand as a product of two factors. One of which is the largest perfect nth power that is a factor of the radicand. So in this first example, my product of two factors was 4 times 6. The largest perfect square that was a factor of 24 was the 4. I apply the multiplication rule for radicals and then simplify the radical that does simplify. In this case, when I apply the multiplication rule, I obtain the square root of 4 times the square root of 6, and then I simplify the square root of 4. I ended up with 2 square root of 6. In the second example, I get that the square root of 3200 is the square root of 64 times 50. Here, 64 is the largest perfect third power that is a factor of 3200. Then I apply the multiplication rule for radicals to split up the cubic root of 64 times 50 into the cubic root of 64 times the cubic root of 50. Then I simplify the radical that does, in this case, the cubic root of 64. What is the cubic root of 64? It is 4. So my answer is 4 the cubic root of 50. Our last example, the method was obtain or simplify the fifth root of x to the 17. First, we notice that the largest perfect cube that is a factor of x to the 17 is x to the 15. So I break or I factor x to the 17 into x to the 15 times x squared. Now I apply the multiplication rule for radicals, which says that the fifth root of x to the 15 times x squared is the same as the fifth root of x to the 15 times the fifth root of x squared. And then I simplify the radical, fifth root of x to the 15, which becomes x to the third. So our simplified answer, x to the third times fifth root of x squared. Okay, let's do some more examples. Simplify the given radical. Let's begin. Square root of 54. In this case, when we are taking a square root, the index is 2. So I want to factor 54 into two factors, one of which is the largest perfect square, that's a factor of 54. When you do your analysis of expressing 54 as a product of two integers, you end up obtaining that the factors you're looking for are 9 and 6. 54 is 9 times 6. Here 9 is the largest perfect square, that's a factor of 54. Now you apply the multiplication rule for radicals. So you end up with the square root of 9, the square root of 6, which is equal to 3 square root of 6. The cubic root of 128. Now I want to express 128 as the product of two factors, one of which is the largest perfect cube, that is a factor of 128. If you prime factor 128, you find that 128 is 2 times 2 times 2 times 2 times 2 times 2 times 2. We're looking for the largest perfect cube. There it is, 2 to the 6, which is the same as 64. So the cubic root of 128 is to be split up into the cubic root of 64 times 2. Use the multiplication rule. So you obtain the cubic root of 64 multiplied by the cubic root of 2. Now the cubic root of 64, we know it's 4. The cubic root of 2 is just that, the cubic root of 2. So there is our answer. Next example, simple one. The square root of x to the 11. Here the index is 2, so we are trying to split up x to the 11 as the product of two factors, one of which is the largest perfect square that divides x to the 11. When you look at perfect squares that are factors of x to the 11, you run across x squared, x4, x6, x8, x10. I'm not going to use x12 because x12 is not a factor of x to the 11. Here's my largest perfect square that is a factor of x to the 11. So I split up x to the square root of x to the 11 as the square root of x to the 10 times the square root of x. But then what is the square root of x to the 10? It's x to the 5th. So we end up with x to the 5th, the square root of x. Example number 4. The cubic root of 625 a to the 17, b to the 13. Here the index is 3. So I need to write this expression as the product of two expressions, one of which is the largest perfect cube, that's a factor of the expression. So let's begin with 625. What is the largest perfect cube that is a factor of 625? It has to be 125. So 125 times 5 is 625. This is the largest perfect cube that is a factor of 625. Now let's look at a to the 17. I want perfect cubes. You could say a third, a6, a9, a12, a15, a15, a to the power 15. What's left? How do you get a to the 17? You need a 2 there. A to the 15 times a to the 2 is a to the 17. Here is my largest perfect cube, factor of a to the 17. The largest perfect cube that is a factor of b to the 13 is b to the 12. Then I need ab to get b to the 13. Next, I apply the product rule for radicals. So I get the cubic root of 125 a to the power 15 b to the power 12 times the cubic root of 5a squared b. Simplify the radical that does simplify. In this case, the cubic root of 125 becomes 5. The cubic root of a15 becomes a to the 5. The cubic root of b to the 12 becomes b to the 4 times the cubic root of 5a squared b. So that's our answer. Let's skip example 5 and do example 6. Simplify the cubic root of 81x to the 4th over 1024 y to the 11. Okay, so let's begin by splitting up this radical of a fraction as a fraction of radicals. There is the rule that says that the nth root of a over b is the nth root of a over the nth root of b. I'm going to use that right now. My numerator is the cubic root of 81x to the 4th. My denominator is the cubic root of 1024 y to the 11. Now, let's simplify the cubic root of 81x to the 4th. I want the largest perfect cube factor of 81. If you realize that 81 is simply 3 to the 4th, you will be able to see that the largest perfect cube, that's a factor of 3 to the 4th, is 3 to the 3rd. What's left? 3 to the 1, which is 3. The largest perfect cube, that is a factor of x to the 4th, is x cubed. What's left? X. That took care of the numerator. Let's take care of the denominator part. I would like to obtain the largest perfect cube that is a factor of 1024. Let's observe that 1024 is actually 2 to the 10. When you prime factor 1024, you get 2 to the power 10. So what we want to obtain is the largest perfect cube that is a factor of 2 to the 10. It won't take too long to realize that that is 2 to the 9. The largest perfect cube that is a factor of y to the 11 is y to the 9th. Okay, let's see what's left. I have 2 to the 9. I need 2 to the 1 to complete 2 to the 10. I have y to the 9. I need y squared to complete y to the 11. Now simplify. In the numerator, the radical that simplifies. Simplify in the denominator, that radical that simplifies. What is the cubic root of 3 to the 3rd? It's 3 to the 1, which is 3. What is the cubic root of x cubed? Simply x. And then we write what's left, which is the cubic root of 3x. In the denominator, the cubic root of 2 to the 9 is 2 to the third, but 2 to the third is 8. The cubic root of y to the 9th is y to the third. And then I have the cubic root of 2y squared. This is our answer. An observation. In a later installment, we will learn that the answers that are fractional are desired without radicals in the denominator. In a later installment, we'll learn the process that will get rid of that radical in the denominator. The process is called rationalizing the denominator. For this lesson, this suffices. Let's quickly display these solutions. You can pause the video to view them. That's all for now.